Welcome back to the course. So, for a damped single degree of system, free single degree of system, there can be three types of response depending upon the value of your damping coefficient in the system. So, what we will do is, I have got two solutions. So the response will be, I will explain this figure. So the response will be basically again C1 e raised S1t plus C2 e raised S2t. I don't dive deep into the mathematics of things, but now we have the different S1, S2 here. We will plug those things here. C1 and C2 will be evaluated from the initial conditions. Okay, let's take the case of O underdamped first, okay, where C is less than 2 root km. So after plugging in all these values, this will be the equation. X of t is equal, where capital X is the initial displacement, into e raised minus zeta omega and t, and whatever I have given. This will be the phase of the system. Now the response will be something like this. There are a few things we need to understand. See, the amplitude is exponentially decreasing because there is damping in the system. In undamped cases, if you remember, the amplitude was constant. Okay, and moreover, there is some periodicity in the motion. So that period, which is called the damped time period or damped natural frequency, as you can see here, I can write this as cos of omega dt minus 5, where omega d will be omega n times root of 1 minus zeta square. So this will be the damped natural frequency of the system. This is the undamped natural frequency, where this is the damped natural frequency. Okay, this kind of systems you can see in your bike dampers. So in the first lecture I explained you what is a bike dampener, because whenever you get into a gutter and while you are riding on bike, you will feel the comfort when it comes back to its equilibrium position within a very slowly. So this kind of system, usually bike dampers will be designed like this. Okay, now the other thing is, this is critically damped when C is equal to, this is critically damped when C is equal to 2 root km. Very important. See, there is no periodic motion. The motion is completely aperiodic, and the other important point is it comes back to it in equilibrium position with the least time. You might have seen the doors in offices and in libraries and all. So what happens, there will be a damper right behind the door. Once you open it, it should go back to its original position or equilibrium position with least time. So all those dampers which you will see right at the back, right behind your office doors or your library doors, will be designed according like this, because it should regain its equilibrium position fast. Similarly, for overdamped, there is no much greater physical relevance to overdamped systems. The motion is again not periodic, but it takes a bit more compared to critically damped. It takes a much more time to come back to its equilibrium position. So I hope that makes sense. So these are the three different kinds of responses that a single degree of freedom free damped system can have, depending upon the value of damping coefficient in the system. This is very, very important. And only in one case the motion is periodic, and in the rest of the two cases the motion is aperiodic. Thank you.